Hi there. In our last section, you learned what the relation between direction cosine and direction ratios are and how to find the direction cosine of a line passes through a given point. In this section, you are going to learn how to find the equation of a line, such as a line passes through a given point and parallel to the given vector, and you will also learn how to find the equation of a line passes through two given points. So let's begin. Equations of line. At first, what we're going to do, we are going to find the equation of a line passes through a given point and parallel to the given vector. So let's start. Passes through a given point and parallel to a given vector. Let vector A be the position vector of the given point P with respect to origin, and line S is passing through point P and parallel to the given vector B. Let vector R be the position vector of the point R at the line S. At first, I'm going to draw all these information on this three-dimensional plane. So as you can see, this is my x-axis, this is my y-axis, and this is my z-axis, and this point is origin O. Let's first consider a vector B. So this is my vector B. I'm going to consider a point. So this is my point P. Let's consider line S passes through this point. So this is my line S passes through point P, and this line is parallel to vector B. Let's consider another point on this line S. So this is my point R. Let's suppose that the position vector of this point P is vector A and the position vector of point R is vector R. As you know, vector PR is parallel to vector B because that's what we have started with. Then vector PR can be some multiple of vector B. So we can write vector PR is equal to K times vector B, where K is a constant. Vector PR is basically position vector of R minus position vector of P, that is equal to K vector B. And as you know, OR is vector R, so it's right here. OP is vector A, which is over here. So we can write vector R minus vector A is equal to K times vector B. If we further simplify, we will take this vector A to the other side, and if we do that, we can write vector R is equal to vector A plus K times vector B. And this is the equation of a line passes through the given point and parallel to the given vector, and this is the vector form of the equation of a line. Let's find the equation of a line in the Cartesian form. Let us consider the coordinate of the given point P as x1, y1, z1, and the direction ratios are a, b, and c. Then the Cartesian equation of line, this line is written as x minus x1 over a is equal to y minus y1 over b is equal to z minus z1 over c. And this equation is the Cartesian form of the equation of a line when we have direction ratios as a, b, and c. Let us consider a situation where the direction cosines are given as L, M, and N. Then the equation of the line in the Cartesian form is given as x minus x1 over L is equal to y minus y1 over M is equal to z minus z1 over N. And this is the Cartesian form of the equation of a line when the direction cosines are given.